Hello, I haven't done a video in a while, and this video is about a mod. Now this mod is not very known. I just figured out that it exists, and it's absolutely amazing. It's one of the mods that just pushes realistic to the next level in this game, because what they're trying to go for is realism, and they really did do that. So here, in this world, I made a power station, and the power station is powering this light, which is a 200-volt light. You might see a bunch of other lights here, and there's the power station. Here's my makeshift transmission lines here. High voltage transmission lines and a transformer with a high voltage bushing coming out the top like you normally see. And then it's just a mess here. So in order to power all these lights, I have this contraption here. If I enter the building, there's a bunch of crazy stuff going on here. I have some screens. There are two sides of the building, and I have some screens here showing me the status of both the sides. So in this side, it's using like 3 amps or something, and same here, because the load is balanced between both of the sides. And it's at just over 200 volts. I'm not sure why it's just over 200 volts, because I have these set at the optimal percentage for the optimal degrees for these turbines to run, which is 350. Every one of these is 350, and I'm still getting just over 200 volts, which I'm not supposed to get. I'm supposed to get exactly 200 volts. But I'm not the mod developer, so maybe that's just something I didn't know about. I have some breakers here in case I connect the wrong wires, which I do a bunch of times when I was building this. But other than that, this is the control part of the system. I can break one of these switches. The current draw goes down to 0, and this one doubles to sustain the lights here, and vice versa. If I do this one goes to its normal one, and this one splits in half. And of course the voltage fluctuates a little bit as the system rebalances the load through the new network, since I switched off part of it. And yeah, so these are some really cool little modules here. These are totally independent, and they all control themselves, and it has some cool little math here in order to figure out what the best stuff is here for the load. And to run these doohickeys here, and I have some temperature probes to make sure that these aren't going out of whack. I have some stuff here, some machines running off of 50 volts. The rest of the system is 200 volts, but here's my backup power in case I blow something up and I need some lights to work. So here's some backup power. These are 50 volts each, and that adds up to 100 because there's like a bunch of them running in parallel in series, 2 of them going in series, and it takes 100 volts. Now the power here is 200 volts, and these are pretty cool here. This is a relay. This switches according to these power lines here, but not these power lines, but signal cables, so it transfers a very small amount of power, which is exactly what a relay is supposed to do. And I have a transformer. It's a step down. It's supposed to split the split the doohickey in half here, and have an optimal core here. There are different cores that you can put in these transformers. It won't be as efficient. But here I'm splitting the voltage in half to work with these 100-volt batteries, and then I'm splitting in half again to work with to have 50 volts, and that goes to the 50-volt light bulbs here, and 50-volt machine. Now, the coolest part here is these independent stuffs here. So I'm gonna teach you how to build this stuff. And it's really cool. So I'm just gonna copy this stuff here. It's gonna be in the video description. You can yell and scream at me if it's not in the description. So in that case, I'll just put it in. So this looks like, the roof of this building is a nice place. So let's just actually turn all these items out, turn all these items off, and start from the scratch. So you're gonna need some heat sinks. In this game, this is called something different, but here I can have some turbines and a stone heat furnace. I need a couple of these. Combustion chambers. You need 4 of those for 2 furnaces. And you're gonna need the heat sinks. I forget what they're called in this mod. Here we go. That's a thermal dissipator, that's right. And you're also gonna need some cables, of course, some medium voltage, and copper cables for transporting heat from your furnaces to your turbine. So let's start by putting down the heat sinks, and then we're going to put the cold side of the turbines right beside the heat sink. Now, one thing I found about these turbines is that the less amount of heat sinks you have, the more efficient your system is. That means the less power you have to give to your furnace here in order to make it run. Oh yeah, of course you're going to need fuel. So I like to use coal blocks because they last a long time. You put them in here, and external control because we're going to be using signal cables. And of course the combustion chambers to make these guys run a lot hotter. We're going to have, oops. I accidentally built out of the monster brick stone eggs while building this. Well, anyway, oops, that's in the wrong spot. These are in the wrong spot, actually. Wow, I'm really screwing up now. You have to actually put these one block away like this. External control. And, of course, you need some probes. You're going to need an electrical probe to detect the current draw, and a thermal probe. So you put these guys here. These will detect the temperature of these copper thermal cables, which we're going to place in here. You'll see it spans across. Also going to need a wrench. Wrenches are used to reorientate blocks in this mod. So here I turned it, and here we're going to have a minimum and maximum temperature. So maximum temperature is the delta temperature of the turbines, which is 350, and then the faster, or the closer you put the lower number to 350, the faster the system will adjust. I like to put it at 150. Now what I mean by adjust is adjust to temperature changes. So if there's a new load, the two turbines are going to cool down a little bit. And from fluctuations, the temperature might go out by 10 degrees. And by hiring this number, it'll be more aggressive with the controls to change the temperature back to normal. Put some blocks here, and this is where control panels are going to go. And we're going to put some blocks here, and this is where the finishing voltage is going to go. So this is going to go up, and we're going to also extend that out like this. There's going to be a signal cable going across here, and this is going to be the signal cable that's going to tell the control panel how much load is on the system. So we're going to put a electrical probe here, and this needs a little bit of setting up. So we rotate it, of course. I like to set this like this, just as a little bit of a breaker, because it works as a diode, and it will only let power one way. We're going to set this to current, and set it to 10 amps. And of course put your cable inside, and connect. 10 amps because these cables are rated at 10 amps at 200 volts, and we're going to be running at 200 volts. So maximum is 10 amps. We're going to also put cables here. This one we're going to put last, because that's the one that controls the furnaces. And 2 cables here coming up from the thermal probes. And we're going to have a signal processor. I'll put it right here. And these are like the best things that ever got created. The signal processor and redstone. Because these things need redstone to wire themselves up to do these equations. So I'm going to have an equation here, and I'm going to explain what this equation does later. And press enter, and it's going to combobulate. Oh, one thing I forgot is we need to rotate this so the black part goes to the bottom, and I need to click 2 times in order for it to shift down to the bottom. And we're ready to start the system by placing down the signal cable. So automatically the temperature gauges are going to adjust, and it's going to go all the way to 350 volt or 350 degrees Celsius, which is what these are rated for. Just making sure that my values are correct here. Oh, we forgot one. I knew those were out of whack, but now that we have them finished, these are going to adjust normally. And it's going to stop at 350. You see how this is going actively changing the power, and as this reaches 350, which is at its optimal percentage to 22%, it's going to just stay at 350 with no load on it. It's going to stay like that forever. Of course you need these combustion chambers, because this formula is designed for this system. Let's connect some lights and put a load on the system. You know what, actually? It's a better idea if we just take this down and put it on a machine, like a electric furnace. Okay. An electric furnace. Some of these textures need some changing, like the electrical source, or the probes. There's some black. It's hard to see. Here it is. So this needs to be connected from the back. Oh, yes. You know, connecting from the back. Now we need a, what's it called? A heat maker, or heat generating core. Okay. Let's get the best one here, because I can. We put it in the heat generating slot. Voltage is just over what it's supposed to be, of course, because for some reason, stuff. Now we're gonna have this on, and these are gonna fluctuate a little bit. But you see how the temperature is going up here. Oh, it's at 91%. This furnace, this single furnace, using 1 kilowatt of energy is really using up this thing here. Voltage is dipping. I'm getting some major lag. What's the deal? Okay, that was weird. Well, now this is... I'm really stressing the system here. But maybe this formula needs a little bit of adjusting. But other than that, it's okay. And this is doing great. It's using a hell of a lot of electricity, or was using a hell of a lot of electricity. And we can cook up iron and stuff in here. Cook really fast, because this is really hot. I'm just amazed at how much energy these heat furnaces use up. Okay. Now, to explain this formula, which is the boring stuff. Now, it's a really simple formula. In these parameters here, I have just the average of both the temperatures. I'm getting another lag spike. What's the goddamn deal, man? Wow, this is enjoyable. Everything seems normal. Okay, now it's normal. It's normal now, okay. So I have the average of both of the temperature sensors. Okay, I'm just going to stay on this screen. So if it does decide to lag up, it doesn't lag up. Okay. So we have this 22, and this is the base percentage, or whatever you want to call it, which is the optimal percentage that the heat furnaces need to be in order to power the generators at the optimal voltage. So 22% makes it go at 350 degrees with no load on it, and I have -1 here just to invert it, because we don't want to hire the power if there's too little load. So of course we unload it, we invert it here, and then we have this plus B divided by 2 times 2.2. So 2.2 needs to be higher a little bit, as I see, but B is the amount of draw from the system. 2 divided by 2 means how many temperature thingies there are. So the 2 heat furnaces, and then 2.2 is just a multiplier to make something decent. Let's turn this off, and let's adjust this. Let's turn this on. It's going to be 90%. Now this, we need to higher to 3.5, 2.5 maybe. So I'm going to adjust this off camera, maybe not. 2.2 is pretty reliable actually, so I'm going to stay there. It's using too much voltage. I can't believe it's using that much. But that's the end of the video. This mod is super cool. I advise you to check it out. put this stuff in the description, and of course this in the description, and that's it.